Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at the University of Albany and Seth's brother Joel here. We are here to hopefully show you how to approach SAT math questions. This is from a calculator section, and here we go. So you should read it, try it, stop it, and then come back. Jim has identical drinking glasses, each the shape of a right circular cylinder with an internal diameter of 3 inches. He pours milk from a gallon jug into each glass until it is full. If the height of the milk in each glass is about 6 inches, what is the largest number of full milk glasses that he can pour from 1 gallon of milk? So this takes a little digesting, doesn't it? I mean, let's see. You have, wait a second. He has identical drinking glasses. Fine. So, oops, sorry, Seth. I know you like to be in smaller things. He has identical drinking glasses. Right? Let's draw some pictures. Each of the shape, right? And then the diameter is 3. So let's make the radius 1.5, because we know we're going to have to use the radius. Be careful, be careful, be careful. Radius is 1.5. He pours milk from a gallon jug into each glass until it's full. If the height of the milk in each glass is about 6 inches, what is the largest number of full milk glasses that he could pour from 1 gallon of milk? Look at this. There are 231 cubic inches. Let's keep in 1 gallon. Right? Now, the volume, you need to know the volume of a cylinder, which I think is given to you up there on the reference sheet. So the volume of the cylinder is this times 6. Okay? So Seth and I are working together like we should. We're a team here. So the volume is this thing times 6. This is a calculator question, by the way, so we better get our calculators ready. So this is the volume of 1 glass. And the computer thing froze, of course. This is the volume of 1 glass. So the question is, how many of these make up 231, right? That's basically what's going on, right? How many of these do you have to make up 231? So why don't we do that? 3.14 times 1.5 squared. I know that 3.14 is 2.25, right? 1.15 is 2.25 times 6. Oh, 42.4. 42.4. Notice these are pretty far apart to the other, so we can be approximate. 42.4 cubic inches per cup, right? And we have 231. So how many 42.4s are there in 231? That's essentially what's going on. So we have 231 divided by 42.4, and you get 5.4. Oh, 5.4. So 5.4 of these cups make up a gallon. So now we have to read this really carefully. Is it 5 or is it 6? Okay, let's be. If the height of the milk in each glass is about, so what is the largest number of full milk glasses he can pour? Yeah, right. That's right, because if you do 6, he wouldn't be able to fill them all, right? So you have to go to the lower number. Sometimes you have to go to the higher number. In this case, you go to the lower number. Good teamwork, Seth. Good teamwork. So I didn't make any fancy ratios. I mean, not fancy. I didn't make any ratios like I personally like to do with the units and everything like that. I just sort of thought about it and did it on the fly. I don't know if we need to go through and make the ratios with the units and the cross multiplying and the whole thing, or whether this is just a good enough answer. What do you think, Seth? What do you think? I did most of the talking. Why don't you?
Just divide. You need to figure out the volume of 1 full glass,
Right.
which is this, and then divide it into the volume of milk that you're distributing, which is given to you in units of cubic inches.
Right.
You take this number, divide it into this number, and you got 5.4 That means that if you imagine filling up the glasses from the jug of milk, you'll fill up 5 full glasses, and then you put the remainder of the milk into the 6th glass. It will be only 4/10 full. It will not be completely full. So the number of glasses that have been completely filled is 5, and so the answer is 5. I didn't talk about rounding down. I just thought about filling the glasses and what the division means.
Yeah.
This means that, 5 quantities of a full glass fits into the gallon, and then there's some left over. Right? And the leftover is 4/10 of a full glass.
Yeah, but I'm hoping that the idea is that hopefully you've done enough of these types of questions in your math career in school so that you could do the problem like this without having to formally set up the ratios, and you just sort of walk it through like Seth and I did, as opposed to doing it more formally.
Yeah.
Right. Yeah, because
right. So it's an arithmetic problem combined with some geometry.
Yeah.
Pertaining to volumes of. Now, how was the formula for the volume come from?
Good idea. Let us go up.
What we do is imagine.
Seth, no. The formula for the volume comes from the reference sheet that they give you.
Reference.
I know. Time to scream.
Let's look at the reference sheet. Okay, let's blow up the reference sheet.
Here's the reference sheet. I'm telling you.
For this, okay, blow up the cylinder.
Here, this.
Yeah, there it is. It's right there. Pi r squared h. Oh, horrible.
Why is it?
What's this come from? The idea is.
I think peaceful people.
Look from here. This formula gives the area of a circle. Imagine this circle sitting on top of there. Right? The area of the circle is pi r squared. Right? So this part of the formula is the area of the circle whose radius is r. Right? That's the area. And then imagine that the cylinder is divided into little slices. Each slice is 1 unit thick, right? So the volume of one slice is, 1 unit of thickness times the area. And then the total volume is the number, possibly fractional, of the number of slices. Like it might be 1 3/4 slices.
Right.
The 3/4 slice contributes a volume of 3/4 of one slice. But all in all, to get the area, we multiply to get the volume, we multiply the area of the top by the number of slices. H is the area. This is the area is given by this formula, and the number of slices equals the height, which is given, is h. So the volume equals pi r squared, which is the area, times height.
Right, exactly. Right. And then
so that way you don't have to memorize this formula. What you do, so that relieves you of one step of memorization. The only memorization that you need is the memorization of the area of a circle.
I know, but in practice, they give you, think about it, they give you the reference.
Okay, but it's quicker to think of it yourself than to flip back a bunch of pages for the formula.
Of course it is. But let's say you don't remember.
Advice to approach studying for SATs and doing SATs is to practice thinking more and more fluidly, so you don't have to take the time to look back at reference sheets.
Right. Hopefully, many people, but not everyone, many people will know that the volume of a cylinder is the area times its height. Same thing, by the way, with what they call the prism, the box, the rectangular prism. It's the same thing, the area times the height.
Same idea, right?
The idea
frankly, the one fact that is very subtle. It's hard to imagine why these formulas are true. For the case of pyramids and cones, there, the volume is similar. It's the area of the base times the height, but you multiply by a third.
Right.
Why is it a third?
So, at the level we're
Do you know why it's a third, Joel?
Well, first of all, at the level we're talking about, let's be honest, nobody cares.
You don't know, don't you?
Wait, stop. First of all, at the level we're talking about, nobody cares. Nobody cares. Maybe, fine. The people heading off to, professional math will care. But frankly, nobody cares. You just use the formula, you're done with it. But it has to do with the fact, because you could fit a certain number of cones in a square.
You fit three.
Yeah, you can fit 3 cones in a square. Yeah, it's related to that.
But personally, I find that hard to visualize.
So do I. Of course, that's
I don't know it all. I don't have the picture of why it's 3 in my mind. I've seen it. I've thought through it a number of times. And saw it fit, and also it could be calculated using calculus.
Right. Yeah.
But aside from that, I don't have an intuitive vision.
Yes.
Of why it's a third.
Welcome to the world.
So unlike the advice we give for volumes of prisms. Essentially a rectangular solid and a cylinder are prisms over a rectangle and a circle.
Right.
The volume of that is pretty obvious, but if you take a prism and you shrink the top to a point, you get a cone or a pyramid. The volume shrinks by a factor of a third.
Right.
So what it means is the volume of three of these cones will equal the volume of the cylinder with the same base and height.
So let me make a plug. If anyone wants to see.
Okay. So my point is contrary to the advice of learning to forgetting about memorizing the formula for the volume of a rectilinear solid or a cylinder. You do have to memorize the formula for the volume. For many people, have to memorize the formula for the volume of a cone or a pyramid.
That's why they give it to you.
Yeah.
So now, if we're going to make a plug for this amazing website called this amazing thing in the world. I don't know what you really want to call it. GeoGebra. I think I'm misspelling it. But
GeoGebra. Yeah.
GeoGebra, something like that. I'm misspelling it horribly. But just type something like GeoGebra cone or prism, and I bet someone will have made a project, and this is all free, where you want
to try it?
No, I don't want to try it. I don't want to, but someone else can. You do GeoGebra and say, how many cones can you fit in a cube, in a box, okay? And I bet someone will have shown a cool way to visualize this.
Yeah.
And if you
Okay.
want
Yeah.
to, you can
I'll
do
have
that.
to do that.
And
Yeah.
Seth will do that, and we'll check that out. But I don't think we need to do that ourselves. But just and by the way, if you have any problem visualizing anything like cross sections of cones or cross sections of anything or any geometry thing you got to visualize, do a Google search, type GeoGebra, and type the thing you want to do, like cross section of cone, or anything, and you will be shocked as to what you will see and what you can play with this website.
Okay, I'm going to write GeoGebra.
Yeah, you want to write it correctly?
GEO. Has it at GEO? Okay. How do you spell it? Spell it out, please.
Should we do it?
Just GEO.
Algebra.
A.
Here. GeoGebra.
L.
GeoGebra.
G.
Cone.
B.
Okay.
Here
we go.
A. Yeah, this is Joel's handwriting.
There we go. See, there's
improved
the website.
handwriting. Okay. So it's GeoGebra.com.
Okay, no, Seth, it's there. It's on the screen. Oh, you don't see it.
Okay,
Ooh,
I don't see it. All right.
Sorry,
good.
Seth doesn't see it, but it's here. Seth, trust
everyone
me.
Sees it. Okay,
trust
good.
me, it's on here. It's called GEO and then GEBRA. That's the website. GEO, GEBRA. And trust me, it's on the screen. You don't have to write it on the sideboard because people see my screen. They don't, but you don't see it. Okay. So this is the website you go to, and you just type in Google GeoGebra, this thing, got number of cones in a solid or something, a number of cones in a box, and you'll see some stuff. Anyway, this is a great website if you want to visualize stuff. See, look at this guy. If you're not into the net stuff, this is really an amazing website. Anyway.
Yeah, there you go.
Okay, yeah, you see, we're making this thing this way, we're making this thing this way, we make a net. Oh, look at the net. See, I'm showing everyone how a net turns into a cylinder, which is very nice if you're not sure how a net, whatever, a net turns into a cylinder. Anyway, okay, so that's a good advice today for that.
Yeah.
Okay, I guess we're done?
Yeah.
Okay, everyone. Have a great day. We'll see you tomorrow. And tomorrow is Throwback Thursday, so we go back to the test tests from 20 years ago. Okay, everyone. Have a great day. Bye-bye.